Hello everyone, welcome to our channel, and we have a new circuit here. We have this, a transformer and a header. The transformer is connected to the PCB, and also in this old cube speaker box. Let us check. This is the circuit. We have here the primary windings of the transformer 220, and since we are working with these 220 volts, it is dangerous to work with, so I carefully insulated the terminals of the 220 volts primary windings of the transformer. First, I soldering it, and then I put the shrink tube, then electrical tape, then this glue, so it is fixed. Also, at the other end we have this, a 3-prong connector from an old computer power supply. This is a heavy duty connector. Also, I connect this wire and insulate it with using shrink tubes, and then electrical tape, and then glue gun, the glue, and then electrical tape. It has 4 insulation. Soldering it first, then shrink tube, electrical tape, then glue gun, using glue gun stick, and then electrical tape. So it has a lot of insulation, the 2 wires of the 220. And I'm using this heavy duty connector from an old computer power supply. So this is connected to the back of this cube plastic, and then we inserting to the cube box. So we have here now our transformer module. I'm using this a 12 volts supply, although this has a lot of multiple output here, 6 volts, 3 volts, 4.5 volts, 9 volts, but I'm using this 0 volts located at the uppermost, and then the bottom, the below, is the 12 volts. Only the 2 line I use in the circuit. So let us see the other module. This is a LED header, resistor, and a male header. Also, we have this module, a series LED, 8 pieces, 5mm in size, female header, and we have this 3 module. So let us connect it to the transformer, and then we're going to plug this into 220. There we have the light. Did you see the light? It's pulsating. So in here, the LED is pulsating upon connecting to the transformer. And this is something like this one, also pulsating. This is a previous circuit project Also, we have this a stable LED light, not pulsating. What are these circuits and what makes this LED to pulsate? Okay, let us again turn on the light and let us now connect this series LED. Okay, connect it in here, the negative. Let us say this is the negative part of the circuit and the positive part, the other end, and then we have this. It is a pulsating LED in series. So, when we're connecting the LED directly to the transformer, it is something like this, a pulsating LED. So, let us check the circuit diagram. What makes this LED to pulsate? Again, disconnect. Power supply and then the module. I'm using this kind of transformer, multiple output. It said here 0 to 12 volts and it has a current rating of 200 milliampere. Let us see the circuit diagram. So this is the circuit diagram. First, I connect the LED to the 0 volts and 12 volts via header, and also I connected the series LED into this terminal 0 to 12 volts. This is our first module, the transformer. So we have the 220 here, the primary windings, just like this one, 220, 0 volts. And then the secondary windings, this secondary windings, it has multiple outputs. I'm using only this, 12 volts and then 0 volts. 12 volts, 0 volts, connected via this jumper, connected it to the header, rightmost, 0, 12, and then again to the other header. So it means this header is interconnected. Let us check that. And it is reversible. If you connect this here, also you can connect it here like this. Okay, let us do that. Okay, power on and then connect the module. Then the LED turns on. See, also we can connect that the other way. There the header is in the right side. Before, it is in the left side. So, we have the second module. LED is connected also to 0 to 12 pin header female. So when you connect that, That is the header. Disconnect it again. So this one now is the module. LED resistor snap-on patch type module. We have an alternate power supply here from the transformer, where I'm going to connect it to the transformer through this header. So that's why LED turns on. Also this one, this is a patch type only. The power input is just female header, this one, and connected positive 12 volts goes to the positive to the anode of the first diode LED, up to positive, negative, and then the negative, last negative, is connected to the 0 volts. So this one, we have positive supply to the positive side of the LED, the anode, cathode, anode, cathode, anode, cathode, until the negative to the ground. That is the series LED patch type module. So we patched that already in this terminal, because according to our diagram, it has 0 and then 12 volts. Also here 12 volts. Also here you can reverse the connection of this, either here or this way or this way. So that is reversible. But the question is, why is it, what makes this LED to pulsate? And this transformer, we got 12 volts supply. But in the battery, we also have 12 volt supply. So let us see that. We're using this 12 volt supply, or this one. Let us now patch the 12 volt supply to this 6 LED series. And then power on. It's not pulsating, it's steady, because this is a direct current. But here, let us again patch that. Okay, patch it to the other end. 0 is to 0, and then 0 again, or I mean the 12 volts positive supply to the other end. So we have here did you see the difference? The other one is glowing, the other one is not pulsating or glowing. But the two has same voltage rating, 12 volts. This one is from the transformer, 12 volts supply, and this one at 12 volts from the direct current. But in the transformer, it is capable of lighting this LED up to 8 pieces. 2, 4, 6, 8. In DC, it has only 6. So every time you see these 12 volts in the transformer, it is not the same with the 12 volts of the battery. or the direct current, because these 12 volts in the transformer is what they call voltage RMS or voltage AC, while in the excuse in the battery, voltage DC. So this one, the voltage here is DC, this one is AC. That's why the LED is pulsating, because the voltage from the transformer 12 volts is not a DC. This is voltage AC, or they call it voltage RMS in the technical term. So let us see that. Let us see. Let us see the diagram. So we have now here the diagram. Secondary connected to the header, and also we have the second module, header here, then again a header here, also the third module, series resist LED here to the header. This is an alternating current. This is 220 volts 60 hertz AC, and then it is the current flows from 220 volts to the primary windings of the transformer, inducing a voltage to the secondary windings of the transformer, because this is a step down transformer, and you will see this rating 12 volts. That is not a 12 volts DC voltage. This is 12 volts RMS, which is equal to 12 volts. If we're going to plot the waveform, this is the first waveform, or the first cycle, the second cycle. So it means we plot the waveform, y-axis, x-axis, voltage input of 220. First cycle, second cycle. It means if it occurs in 1 second, it has 2 hertz, 2 cycles per second, or from this point to the 0, what is the period? 2 seconds. For every 1 period, it has 2 cycles, so 2 cycles per second. For every 1 second, 2 cycles per second. So 2 cycles of sine wave. That is the alternating current provided by our electrical company. 220 volts, 60 hertz, frequency 60 hertz. Always. And in here, the BRMS is located somewhere here at the positive side of the curve of the wave. So the 12 volts here is the BRMS. We're going to convert that into voltage peak by using this formula. BP, voltage peak, is equal to BRMS divided by 0.707, 12 volts, divided by 0.707, and now we have this voltage peak, 16.973 volts. It means the voltage peak here, this is not voltage DC, voltage peak is 16.973 volts. That's why it is capable of lighting this 8 LED. And we know that the voltage rating of the LED to turn on is 2 volts. 2, 4, 6, 8, 10, 12, 14, 16. So it means that is the voltage peak. That is the rating of the transformer in voltage peak. That is the actual rating, voltage peak, and this one is a direct current, which is 6 volts direct current. And a 12 volts BRMS is different from 12 volts direct current. 12 volts AC is different from 12 volts direct current. Direct current flows only one direction. So the current flows only in one direction. While the voltage at AC is flowing back and forth because this is alternating current. So it means these 12 volts we have in the transformer is not the same as the 12 volts of the battery or the direct current. It is the BRMS, and we're going to convert that BRMS into voltage peak or BP using this formula, so that this is now the total voltage. That's why it is capable of handling 8 LED in series. And what makes this to pulsate is because this is alternating current. It makes the current to turn on and off during the reversing of the wave, because this is an LED, and we know from here during the positive cycle LED turns on, and to the negative cycle it is turned off, so it acts like a rectification, making the circuit AC to DC. But we are not using any kind of components here, only a series LED. So since this is the maximum LED it can handle, the transformer it can handle, and it is in terms of flexibility, it is not good to design or to make this kind of circuit, because of the possible voltage sudden voltage change or voltage surge, because the peak and burst voltage of the LED is very low. Let us see what is that. But before that, let us compute for the current peak. Since we know the voltage peak, that is now the actual voltage rating of the transformer. BP is equal to IP over R1 according to Ohm's law. So voltage current peak is now 16.973 substitution, and we have to the load 1 kilo ohms. So we got 1 kilo ohms here. So we got now 0.01678. I'm talking about this kind of LED. The other one, when we're going to use this. So it has peak current, peak current of 0.0167 ampere or 0.02 almost. That is enough to turn on the LED. Let us we can explain the peak and burst voltage using our last project. And what is that? We also have that kind of project. The last one, we have this. Did you see that? It's pulsating, while in here also pulsating. But let us connect the other one. Again, connect this to here. Now we have now this, and again connect it. We have this last project, we have this kind of circuit. What is this? Let us compare the two. Oh. This one is pulsating, And this one is pulsating also. What's the difference? I think this one is a little bit slower than this one. Did you see the difference? It is much faster. This is faster than this one. So let us see the circuit. The circuit of this last old project or the previous project is this. We have this, a transformer 1N4001 circuit. So in this circuit we have the diode 1N4007, and then connected is this, our load, the resistor and the LED. So what makes this to pulsate slower than the other one? This has a diode here. It has a voltage drop of 0.7 volts. So during the first cycle of the wave, it conducts, and then the reverse, it will not conduct. So this is now the final waveform. It conducts during the positive cycle, and then to the negative cycle it will not. What's the difference between the two circuits? What do you think is the difference? In here we have a diode, of course, the LED and the resistor. In here we don't have a diode. So let us check the current flows. When the current flows during the positive half cycle, this one, into this circuit, it flows it to the LED, turning on the LED and then to the ground. And when it reversing it, this LED will turn off. But the problem with this LED is it has a low intrinsic voltage rating. During the reversing of the direction of the current, it will make the LED to damage a little, to at least. Unlike with the diode here, during the reversal of the wave, it protects the LED because it has a greater peak inverse voltage during the negative. That is now the PIV, peak inverse voltage, which is necessary during the negative or the reversal of the wave. Remember, positive half, negative half. During the negative half, it will protect the LED from damaging or serve as a protector because it has a high peak inverse voltage rating and can be found in the data sheet of this 1N4007, and I think this is about 50 volts or 30 to 50 volts, and the current that flows here is 12 volts, so it will not flow here during the negative, making this wave because there it has you cannot break the it has a 50 volts peak inverse voltage, and making this diode to cut off to protect the circuit. Because of this LED is much durable than this kind of LED, because this diode is durable, or I mean flexible in terms of usage with respect to this LED. It has low intrinsic peak inverse voltage, so it cannot protect itself. So this one, during the reversal of the wave, when you connect that to the transformer through the header, as we know, during the positive and to the negative, since it has no resistor, when we use this series LED, it has low intrinsic peak in burst voltage. It means the possibility of damaging the LED is could be possible, and the circuit is not functioning well. So that is the second circuit. And now we have this, the other one. Let us connect. What's wrong? Pulsating. This one is steady. Let us see the circuit diagram. This is the circuit diagram. This is a full wave rectifier center tap. We have two diodes connected using the two windings of the secondary of the transformer, secondary windings, and the center tap is connected to the negative of the capacitor and to the load, positive to the load. So what happens here is during the positive half cycle, this one is conducting and then charging the capacitor. So we have the capacitor here, that's why it has a steady light. And then during the negative cycle, this one now is negative, this one is positive. This will now conduct, charging again the capacitor, so it maximizes the use of the two wave. This one is for the first diode, the positive wave, and then the other one is for the negative. When this is negative, this is positive, this is positive, this is negative, the reversal of the wave. So making this to conduct into the to charge the the capacitor and discharge it to the load. So what is the purpose of this capacitor? Is to filter the waveform. During the positive cycle, it's just like a seesaw. When this is plus, this is minus. This is minus, this is plus. Just like a seesaw. When one is up, the other one is down. When the other one is down, the other one is up. So when this is positive, this is negative during the positive cycle. First cycle, since we are using 1 Hertz. So this is negative. Again, it reverses the direction, become positive, and this one is negative. So in this terminal, 12 volts, this is a center tap, which is also available in the market, 0, 12, 12, just like this one here. 0, 12, 12. The other two terminal is connected. The one into the diode 1, diode 2, and then the center tap is connected to the ground of the capacitor and this LED. So the voltage output of this 12 volts is 6 volts because it only utilizing using this positive half cycle, and the other one was also 6 volts during the another positive half cycle. All in all, it becomes 12 volts. What make this? What is now the current rating of the primary? It is 24 volts, the sum of the 2 volts. 12 volts plus 12 volts, 24 volts, making this a center tap. Since this is using 12 volts, only utilizing the positive wave, positive half cycle, it becomes 6 volts. Also, the other one 6 volts, this is 12 volts. So making this a 12 volts. The sum of the two, 6 volts. With the use of the center tap rectifier, it is using too much power, 24 volts, and then it becomes 6 volts here, and 6 volts, 12 volts, outputting the capacitor, and now the capacitor is now discharging. So the one that is supplying the voltage here is the capacitor, making this a pulsating direct current. But with the help of the capacitor, is smoothing out the waveform. During the first half cycle, first diode, the second half cycle, second diode, and with the help of the capacitor, it filters out. So a little bit smoother, sawtooth type. But this is not a pure DC. This is pulsating DC. But you can see here, it's not pulsating. It has a fine LED circuit, lamp. But still, this is not yet a direct current regulated. But it is almost. You cannot see it. So that's why. That's the difference between 12 volts AC and the transformer, and then the DC in the battery. That's the difference. So when you connect anything to the transformer at the secondary winding, when this is 0 volts, 12 volts, that is not the actual rating of the transformer. That is the BRMS. And you have to convert that in voltage peak to make this a circuit that works in an LED in series. So let us check this one. What makes this LED in series to glow or to pulsate? Because if we know that the voltage rating of the LED is 2 volts, it seems that other LEDs are not glowing, or are not glowing so bright, or functioning well, or having the same brightness as the other LED. It seems that the LED is having this dot, or this kind of voltage. Somewhere around 1 here, 1.5, 1.8, 1.9, and then the other one is having a little 1.7, the other one's 2. That's the voltage drop of the LED in series during the positive half cycle. And then to the negative half cycle, there's no output. So this is the waveform output of the series LED. And with this, and the light shows that others will not light, and the others have this good light or brightness, and that's the explanation of the transformer, 12 volts, and what makes this LED to pulsate. Pulsating, 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 pulsating. This one is no pulsating because of this, not pulsating because of the capacitor. Okay, that's it all folks, and thank you for watching. Bye bye.